In this video, we will explore the equation of a circle. So to start off with the definition, a circle is the set of points that lie a fixed distance, i.e. the radius, from a fixed point, the center. So in terms of the equation that we have, you have the center of the circle, let's call it h comma k, and we want all points which are r units away from it. All points r units away from hk traces out this circle. And the equation of the circle with the center h comma k and radius r is given here. Now to give you a very simple idea of where this equation comes from, if we apply the distance formula to the picture that we have, the distance between the point hk and xy is going to be r. So in order to find that distance, we take the square root of the difference of the x-coordinates squared plus the difference of the y-coordinates squared, and that is all equal to r. Now if we square both sides, we end up with exactly the formula for the circle. So a very common question. Write down the equation of a circle with a given center and a given radius. So to make the comparison to the previous formula, the 3, 5 is playing the role of the center hk, and the radius is 4. So the equation of our circle is x minus 3 squared, so that's x minus the x-coordinate of our center. We add on to this y minus the y-coordinate of our center squared, and this is equal to the radius squared. So x minus 3 quantity squared plus y minus 5 quantity squared equals 16. For a slightly more involved example now, let's find the center and radius of the circle given here. Now in order to do so, we need to take this expression we have in the left and somehow get it down in terms of the equation of a circle. That is to say, after some algebra steps, we want to end up with, x, I'll say minus something squared, plus y plus something squared equals, some number to fill in on the right. And in order to do that, we need to use an algebraic tool known as completing the square. And the reminder is that if you have x squared plus bx, and you would like to complete the square, how we do so is we take the coefficient of x, which is the b, and we add on to this b over 2 squared minus b over 2 squared. And what this will give us is the first 3 terms is x plus b over 2 quantity squared, and then we have that minus b over 2 squared. So looking at the expression we have, if I have x squared minus 2x, I want that to end up being x minus something squared. Well, the coefficient of x is minus 2, so that's playing the role of b, so we want that to end up being x minus 1. So ideally this is going to be x minus 1. Now note, x minus 1 squared is x squared minus 2x plus 1. So what we are missing above to go with the x squared minus 2x is a plus 1. So x squared minus 2x, I'm going to put in the piece I want, plus 1. And notice that when I put the plus 1 on the left to balance out our equation, I'm also going to put a 1 on the right. Now we play a similar game with the y portion. So y squared plus 6y. I take the coefficient of the y, divide it by 2 to get a 3. So this is going to be hopefully y plus 3 quantity squared. So that would be y squared plus 6y plus 9. So to balance this out, I need to put a plus 9. So plus y squared plus 6y plus 9 plus 9. And what we will have on the right then is minus 6 plus 10, which gives us a 4. And what we now have done is taken the original expression, and by completing the square twice on the left, we now have the equation of a circle. And we should specify the center and the radius. So because it's a 4 on the right, and that's the radius squared, the radius will be its square root 2. And remember the form of the center is h comma k, where it would be x minus h, y minus k. So we have 1 playing the role of our h, but plus 3 is really minus a minus 3. So it's the minus 3, which is playing the role of the k. So our center is 1 minus 3. For this last example dealing with circles, let's find the equation of the circle that has diameter AB, where A is the point 2, 0 and B is the point 10, 4. So I'm going to draw a very generic picture. So we have a circle, and we have 2 points on our circle. So I'm going to go ahead and make this the point 2, 0, and then 10, 4. And this line connecting them is a diameter of the circle. And what it means to say that that line connecting them is the diameter of the circle is if we go to its midpoint, that will be the center of the circle. So to write down the equation of the circle, we essentially need to do two things. We need to determine what is the center and what is the radius. So we've indicated how to find the center already, so let's go ahead and find it. The center is going to be the midpoint of those 2 points. So the midpoint in coordinates will have a first coordinate, which is the average of the 2 x-coordinates of the points, and the y-coordinate should be the average of the y-coordinates of the points. So it will be the point 12 over 2, 4 over 2, which is 6, 2. To find the radius, what we need to do is take, if we look at our picture here, the distance from A to B is a diameter, so 1/2 the diameter will give us the radius. So for the radius, we need to take the distance from A to B and divide it by 2. So the distance from A to B, using our distance formula, will be the square root of the sum of their x-coordinates, the difference of their x-coordinates squared, plus the difference of their y-coordinates squared. And this is all divided by 2. So this will be the square root, so 10 minus 2 is 8. 8 squared is 64, plus 16 divided by 2. So that's the square root of 80 over 2. And in terms of canceling off this 2 on the bottom, we can note that 80 is really 4 times 20. So we can pull the 4 out of the square root as a 2, and we end up with the square root of 20. So we want to write down the equation of the circle with center at the point 6, 2, and radius square root 20. So summarizing this, it would be x minus 6 quantity squared plus y minus 2 quantity squared equals the square root of 20 squared. And I will simply make that a 20, which is why back here when we found the radius, I left it as a square root of 20, opposed to maybe simplifying and pulling out some terms. And we now have the desired equation of the circle.